So first we'll talk about the physical nature of matter, and as I said that matter which has mass and occupies space, and matter consists of very tiny particles. So let us perform this activity to show that matter consists of very tiny particles. So what are you supposed to take? You are supposed to take a 100 ml beaker, fill half the beaker with water and mark the level of water. Now with the help of glass rod, add some sugar or salt into it. Observe the change in water level. Do you find some change in water level? Do this activity and try to find out if there is any change in water level. By performing this activity, you will observe that there will be no change in the level of water. Rather, the level of water will remain same even after adding salt or sugar to it. Now my question is, then where this salt or sugar goes? When we dissolve sugar or salt into water, we observe that there is no increase in the level of water. Rather, the particles of these sugar or salt, whatever you take in the beaker, get into the spaces between the particles of matter. They will go, they will enter and they trap into those spaces of matter. So we can say that these particles are very, very small so that they can easily get trapped into the spaces of those water molecules. So this is how we can say that matter is made up of very tiny particles. And second thing, we can say that they have spaces between them. That's why these sugar or water or salt particles can enter into these spaces and occupy those vacant spaces. Now next question is, if I say that matter is made up of very tiny particles, the question is how small are these particles of matter? So I can say the particles are very, very small, and even sometimes we require microscope, or sometimes even with the help of microscope we cannot see those particles, those small particles. So let us perform another activity to observe that how small these particles are. So what you do is you take around 100 ml of water and add around 2 to 3 crystals of potassium permanganate to it. Potassium permanganate is purple colored solid, and when we add into the water, it becomes light pink color. And what you do is, once you mix potassium permanganate into it, now you take out around 10 ml from this solution into another beaker and add 90 ml of water to it. That means I have taken only 10 ml of this and 90 ml of water, a good number of water, large amount of water I have taken. Still we observe the color is there. Though the intensity of color decreases, it becomes light pink, but still it is colored. Now again take out 10 ml from this third beaker and then mix in the fourth beaker with 90 ml of clear water. After doing this, we observe that still the solution is colored, though the color becomes lighter. And if we continue to dilute the solution around 5 to 8 more times doing this way, still we observe that the color is still there, though it becomes very light. So though the intensity of the solution decreases, intensity of color in the solution decreases, but even after doing so many dilutions around 8 times also, we observe that the solution is still colored. It means that if I have taken only 2 to 3 crystals of potassium permanganate and diluted it so many times, even at the end it has some particles of potassium permanganate in the last beaker, which shows that the particles are very, very small and can get easily transferred with this 10 ml from one beaker to another, again 10 ml to next beaker, and so on. So this activity shows that the particles are very, very small. So finally we can say that the lightening of color with dilution, though it decreases, its intensity decreases, but still the solution is colored. It means that particles are very small and they can transfer from one beaker to another. You can perform this activity by taking a drop of ink with water, or you can perform this activity in your school with the help of your teacher. So when you perform this activity, you can easily identify and observe the changes doing this activity. Let us move further. Now we'll talk about the characteristics of particles of matter. So first thing is, we know that the particles have spaces between them. As I've told you, when we dissolve some sugar or salt into it, the sugar or salt particles, when dissolved in water, they enter or get trapped into the spaces between those particles. So when we mix particle of one type of matter into particle of another, they get easily mixed. It means that there is good amount or ample of space present between the particles of matter. Here you can see in this video that when we mix this milk into the tea or hot water, it gets mixed easily, which shows that there are so many spaces present into it. Another characteristic is particles of matter are continuously moving. That means they do not remain at particular position, rather they keep on moving. And this is mostly observed in the case of gaseous substances where the forces are very weak. So what you do is you just take an unlit incense stick in the corner of a room. You need to smell this unlit incense stick by moving closer to it. But suppose you light this incense stick, what you will observe? You observe that after some time, its smell, its aroma will go even at the other corner of the room. So finally, we can conclude that even by sitting at a large distance in the room, we can get the smell of this incense stick. We can get the smell of this incense stick by sitting even at a large distance. It shows that the particles do not remain at a particular position, rather they keep on moving. And since they are continuously moving, we can say that the particles are not still. They are moving. So this is another characteristic of matter. Now, we'll talk about one more activity. What are you supposed to do? Just take 2 glasses or beakers filled with water and add a drop of blue or red ink slowly and carefully to the side of first beaker and honey in the second beaker. Leave them undisturbed. After some time, you observe that there is change, that where the beaker in which we add some ink starts depositing or diffusing very fast, whereas the another beaker in which honey has been added, it does not get diffuses, it does not get mixed so easily. It means the particle which is lighter, that means less dense or less viscous, can get mixed easily, and the particles in the case of honey which is having more viscosity, have less tendency to float, does not get mixed so readily in water. So it takes some time when you add some honey to it. You can see in this image, it remains as such. Now, let us perform another activity. You pour a crystal of copper sulfate or potassium permanganate in a glass of hot water and another in a glass of cold water and observe without stirring, in which case the solution get dissolved completely or copper sulfate get dissolved completely in the solution. It's very obvious where we are having hot solution, the salt will get dissolved easily. It shows that the dissolution or diffusion takes place faster at high temperature. We can observe this at our home also. When you take a cold water, glass of cold water and sugar to it, you need to stir it. Whereas while making tea in a hot cup of water, when you add sugar to it, even you don't need stirring and it gets automatically mixed, or rather it gets mixed easily as compared to that in cold water. So we can see that the dissolution is more faster, diffusion is more faster when the temperature is high. So you can see this observation, and we observe that the particles are continuously moving at high temperature, because at high temperature they have more kinetic energy. And as we increases the temperature, the kinetic energy of particle increases, and because of this kinetic energy they start moving here and there, and thus they get mixed readily with the water. So in these activities we can observe that the mixing of matter takes place at higher temperature by their own. The particles can move into the spaces available to them, and the intermixing of these particles, as we have discussed in the case of ink and water, we call this intermixing as diffusion. And we know that on heating, diffusion increases. The process of diffusion increases, the rate of diffusion becomes faster. So on the basis of the activities that we have performed, this is the final conclusion. Now another characteristic is particles of matter attract each other, and for this let us perform an activity and then we'll discuss some examples. So you play this game, you make 4 groups and form human chains. The first group should hold each other from behind and lock arms just like the Mishrim dancers. In the second group, they hold hands to form a human chain. That means a little bit apart from each other. A distance is there as compared to first. And in the third group, only the tips of fingers should be touching each other. That means even more away, more apart from each other. The fourth group, they break the human chains and one by one. And the question is which group can be break easily. It is in which group it is more easy to break the human chain. So answer is the third group where the humans, the chains are attached only with the finger. Then the second when they have holded their hands, and the first one when they are actually locked each other behind and arms. So this is how we can observe that the particles which can easily break means they have less force of attraction. You take a piece of chalk, you take a piece of iron nail and try to break both the things. Which one will break easily? A piece of chalk will break easily because it has weaker force of attraction. As we have discussed in this group, which chain will break easily? The third group, because weaker force of attraction. They are just bonded by touching their fingers only. Whereas in the second case, they have holded their hands, and in that way, what will happen? It becomes much stronger as compared to third case. So finally, what will happen? We can easily observe that the particles which are strongly attracted needs more force to break, as we observe in the case of iron nail. Whereas in the case of a chalk piece, we can easily break that piece of chalk just by hammering it. So, by this activity, we can finally conclude that if we consider each person as a particle of matter, the particle which has a stronger force can break very hardly, whereas the particles which are bonded with weaker force can break easily, as I have given you an example of a piece of chalk or iron nail. So let us observe in this case what will happen in an iron nail or a piece of chalk or rubber band. When we observe that a piece of chalk and iron nail and rubber band, all these three are solids, then where is the difference? If we try to break by hammering, by cutting or by stretching, we observe that it is very hard to break iron nail because it is bonded with very strong force of attraction. So particles of which substance are held together by greatest force? One which cannot break easily. So the case of iron nail, we cannot break the substance and thus it is bonded with strong force.